All right, let's dive right in. It's late 2025, and technology is moving at an absolutely breathtaking pace. We are seeing these incredible breakthroughs that could solve some of humanity's biggest problems. But at the very same time, we're uncovering risks that honestly feel like they're pulled straight from a sci-fi movie. It's really a story about immense power and this incredible tension between what we can build and what we can actually control.
And right at the heart of all this is one technology that stands above everything else: artificial intelligence. It feels like every single day, it's forcing us to ask this really fundamental question: is this the most powerful tool for good we've ever created, or are we building something that could seriously harm us? And this isn't just some philosophical coffee shop debate anymore. The evidence for both sides is piling up as we speak.
Okay, so to really get what we're talking about, just look at these two stories that happened almost at the same time. On one side, we have an AI-designed cure, a totally new antibiotic for a really nasty disease. And on the other, an AI-designed toxin, a poison so new and so effective it could slip past 100% of our biological security screens. I mean, you can't get a better picture of the promise and the peril we're trying to figure out right now.
So let's really explore this double-edged sword. How in the world can the exact same technology lead to two such wildly different outcomes? One that literally saves lives, and another one that could threaten them.
First, the amazing news. Researchers used AI to find a brand new antibiotic called intralation. What's so cool about it is that it's super targeted. It goes after the bad bacteria that can cause things like inflammatory bowel disease, but it leaves all the good bacteria alone. But the real revolution here, it's the speed and the cost. The AI didn't just find the drug, it figured out exactly how it works. This cut down a process that usually takes, 2 years and millions of dollars to just 6 months and $60,000. That is a total game changer.
And I love how the lead researcher, John Stokes, put it. He said AI is his wrench. It's not some magic black box, it's a tool for fixing really urgent problems like the rise of drug-resistant superbugs before they become a flood we can't control. It's such a great way to think about AI's potential when it's in the right hands.
But now, we gotta look at the flip side. A team led by Microsoft ran a study to see if AI could be used for something malicious. And using open-source AI, they created thousands of new types of known toxins. The results? Well, they were chilling. These new AI-generated toxins just slipped right past the standard security software, some of them with a 100% evasion rate. Researchers are calling this the first AI biosecurity zero-day. Basically a brand new, undiscovered hole in our defenses, created and exposed by AI itself.
So when you have something this powerful, with this much potential for both good and evil, you know what happens next, right? It kicks off a massive economic race, a gold rush. Let's take a look at the sheer scale of the industry that's building the engines for this whole revolution.
We're smack in the middle of a silicon gold rush. The global market for semiconductors, the chips that run everything, is set to hit a staggering $800 billion this year. And pretty much all of that explosive growth is being driven by one thing: our insatiable demand for more and more powerful AI.
And that wealth is incredibly concentrated. I mean, just look at NVIDIA, the undisputed king of AI chips. Its market value has blown past $4.5 trillion. Just let that number sink in. That is more than the entire economy of countries like Germany or the UK. All of it built on making the hardware that powers AI.
And you can see this ripple effect across the entire supply chain. Take a company like TSMC in Taiwan. They're the world's best chip factory. They build the chips for everyone else. Today, a full 60% of their revenue is coming directly from AI. It just goes to show how the entire tech world is fundamentally reshaping itself around this one technology.
So who are the key players in this high-stakes game? Well, you've got NVIDIA as the kingpin, with its super powerful GPUs and software that kind of locks everyone in. Then there's TSMC, the factory that everyone depends on. And of course, you've got the challengers. AMD is making a really strong push, Intel is trying to catch up with its own chips, and Samsung is battling to dominate the super fast memory that all these AI systems need. It is a massive chess game with trillions of dollars on the table.
Okay, so with so much power and so much money on the line, and with this obvious potential for both incredible progress and real peril, it's no surprise that governments are now scrambling to figure out how in the world to regulate all this.
But actually creating those rules, man, it is tough. Just look at the journey in California, the heart of Silicon Valley. It was a year-long battle to get an AI safety law passed. Their first attempt got vetoed after a ton of pushback from the industry. It took a whole new bill, a special working group, and a lot of negotiation to finally get a law signed. It really shows you just how hard this is.
So, what does this big new law actually do? Well, the key thing is it doesn't try to ban AI. Instead, it's all about transparency and accountability. It basically says to the big AI companies, you have to tell us how you're keeping things safe, you have to report when something goes wrong, and, this part is huge, you have to protect the whistleblowers inside your own company who want to speak up. It's a first real step towards some kind of oversight.
But here's the thing. As powerful and disruptive as AI is, it's not the end of the story. While we're all racing to build rules for today's tech, there's an even bigger wave building on the horizon, one that could make today's supercomputers look like pocket calculators. I'm talking about the quantum leap.
Okay, so what even is quantum computing? Well, in the simplest terms, your laptop uses bits, ones and zeros. Quantum computers use qubits, and thanks to some really weird quantum physics, these qubits can kind of be a 1 and a 0 at the same time. And they can all be linked together. This lets them explore a mind-boggling number of possibilities all at once, which makes them perfect for solving problems that would take a normal computer billions of years.
And yeah, the race to build these things is definitely on. You've got the big tech giants like IBM and Google pouring in billions. You have a whole wave of scrappy startups trying out different approaches. And then you have companies that are kind of like the ones who sold shovels during the gold rush. They're building the software and tools to help everyone else build the quantum future.
And you know, this isn't some far-off dream anymore. The progress is real and it's happening fast. Just recently, we saw researchers build a quantum system that can work at room temperature, which is a huge deal. And we also saw the first real proof that quantum computers can break modern encryption. Sure, it was only a tiny key, but it's proof that the threat to our digital security is very, very real.
Now, I know, all this talk about AI and quantum computing can feel pretty abstract. But this race for more power and smarter design, it doesn't just happen in labs. Eventually, it all ends up in the devices that we hold in our hands every single day. So for this last part, let's bring it all back down to earth.
Let's talk about the next generation of foldable phones. We're seeing two different ideas about how to build them. The G Fold is like a book. The big screen folds inward, so it's protected. The Z Fold wraps the screen around the outside, so it's always visible, but also always exposed. It's a classic engineering choice, right? Do you want better protection or a bigger, more seamless display?
Or how about a problem that has driven gamers absolutely crazy for years? Joystick drift. The fix is just a perfect example of smart, elegant innovation. See, the old joysticks used physical parts that would literally rub against each other and wear out. The solution? Get rid of the physical contact. New controllers use magnets and sensors. Since nothing is physically touching, nothing wears down. The result? Zero drift, permanently. It's just a simple, brilliant fix.
So we end up right back where we started, with this feeling of incredible speed. From an AI that can both cure disease and create weapons, to quantum machines that will completely rewrite the rules of computing, all the way down to the gadgets in our pockets. The pace of change is just relentless, which leaves us all with one final and really crucial question. As we build these more and more powerful tools, who gets to decide how they're used? Who should hold the blueprint for our future?